All right, so we're going to study a little bit for the final. Today will also include such amazing highlights as grading an old homework assignment. I'm not telling you which one. And also making sure that you know where you can get extra one-on-one help from me. Okay, so I'm going to start with that part. Let's say that you're scared after I do this little logs review. You're like, oh crap, I don't remember logs at all, and I need some extra help. You can come in Monday morning for an hour, 7 to 8, like a normal day. Then Tuesday starts our like weird final schedule. But there's 2 hours, in case you hadn't noticed this yet, there's a 2-hour block on Tuesday morning where you can come in and get help right here from me for 2 hours straight. Okay? Now, granted, there'll be other kids here, but from my experience, there's usually only like 5 or 6 kids that show up. So, if you want to come in, you can probably get all your questions answered. If you want to come in on Tuesday morning or Wednesday morning, you can come in Monday or Tuesday or Wednesday of next week in the morning. 1 hour on Monday, 2 hours on Tuesday, and 2 hours on Wednesday. So a lot of time. If you get your questions narrowed down to, I'm really just bad at logs, can you practice that with me? I can do that. All right. So number 2, we are going to grade a homework assignment at the end of the hour, but I'm not telling you which one. Just tell me, just have your homework done and you're fine. All right, anyway, so let's talk about logs. 5 to the x equals 8. I was looking at an ACT test the other day, and they didn't have this, but they had this. 10 to the 3 plus x over 4 is equal to 1. And I get how that looks really complicated at first when you look at it, but as soon as you realize that you could make the bases the same, you wouldn't even have to have logs. My first gut feeling when I saw this was, oh, geez, I wonder if kids would even know that they could write a log for that because it looks so complicated. And then I realized, ooh, good question, ACT, because you're testing to see if the kids are smart enough to go, oh, yeah, I remember making the bases the same in math class, and when I made the bases the same, I could cancel off the bases and just set the exponents equal. All right, so how do I just make a 1 into a 10? You can't, but you can. 1 is really 10 to the what? Think about it. 10 to the 0 is what 1 is, isn't it? Okay, so then all of a sudden the bases are the same. And then, once the bases are the same, it's easy. That's gone, and you just solve this little equation. That equals that. Once you solve that one and figure it out. It's different than the one on top. This one needs logs. But this one, you can just solve a little equation. And they were testing to see if the kid could make the bases the same. Once the bases are the same and they cancel off, you have 3 plus x over 4 is equal to 0. And then I'm going to multiply both sides by 0, or 4. A lot of kids get concerned because they're like, can I do that even though there's a 0 over there? Yeah, you can always multiply both sides by a number. 4 times 0 is just 0. So 3 plus x equals 0. You'll know if you're right because at the end, you'll just check it quick and make sure it actually works. It seems like x equals -3. Raise your hand if you had x equals -3. Good. That was a typical little ACT question thrown in, and it's got a nice little twist. If you know there's an x in the exponent, you might be thinking that's an exponential and therefore could go with a log. But if you know the bases are the same trick, then it becomes no logs necessary. How do I know it's really right? Because look, I put a -3 here. What happens? This becomes 0. Then 0 divided by 4 is still 0. And then it's 10 to the 0 power. And that equals 1, which is what it said in the first place. So it worked. That's how you can know it worked. Okay. So there's a quick, I saw this on an ACT test just the other day, and it could be on your test too. This class, one of the reasons I really like teaching this class right now, the one we're in, which is higher algebra, is that it's got so many ACT type questions on it. When you get to pre-calc, in pre-calc there's less stuff that's on the ACT because the ACT is mostly from this class down. Pre-calc only has like 4 things in pre-calc that you really need to know for the ACT, and it's mostly about trig. So anyway, when you take pre-calc, you're actually beyond most of the ACT. Okay, There's some things in there, just not as much as this class. All right, so how do you do this with a log? I'm going to do the first one just because I know some of your brains would explode if I made you do this by yourself. Log base 5 of 8 equals x. Do you remember how you go around like this? Does that ring a bell? Then you have to also be able to go backwards. What if I say log base x of 3 equals 2? You have to be able to go x to the second equals 3. And is it solved? Not quite yet. What would you have to do? Square root of both sides. Final answer is the square root of 3. So if I had the square root of 3 right here, it would work. Is that legal? Can you have the square root of 3 there? Yeah, as long as you don't have negative numbers in the base. And one other rule, bases can't be 1. All right, so let's see. You try this one. Log base 2 of x equals 5. Solve. That could be right on the ACT test because logs are one of the things you have to be able to do. Did you say 2 to the 5th equals x? Raise your hand if you knew that. Awesome. Even better, what is 2 to the 5th? 32. Very good. All right. So if I wanted to be sure, I could put it back here, but then you'd have to know how to put that in a calculator to see if this is really 5. Why don't you grab your calculator? If you need to borrow one from me, go ahead and do that. Make it fast. And then I want to remind you how you put that in the calc. Because some of you have an awesome operating system that just lets you put them in the way you see it. You can put in the base number. You can put in, this is called the argument. But some of you are going to have to type this. Log 32 over log 2. That's how this goes in the calc. It's also called a base change because it was base 2, but now it's base technically 10. But anyway, if you put that in the calculator like this, you'll get your decimal answer. Just make sure you know how to do that. I'm going to pause for a second while you give that a shot. Okay. The original question, if we go back to the very original question, it was just making sure that this actually equaled 5. When you type this into your calculator, hopefully you got 5. Raise your hand if you got 5. Okay, good. So let me just make sure you got the really easiest part of logs. Use your calculator if you want to make a log statement. Once you know it's log base this of that, put it in the calc and you've got to find a decimal. One of the things that's tough about the ACT is you got to know so many little things like this. You knew this at one point this year. At one point this year, this was like easy for you. And then when we started class like 10 minutes ago, probably a third of you had forgotten how to do this. And that happens. And then there's 200 things like that. You know what I mean? It's just really hard to have everything fresh in your mind. We're going to go over also matrices again today. And you guys rocked that test. You overall did really well. But I bet you might have forgotten a few things. So. Did you get about 1.29 if I remember correctly? All right, awesome. You should have said log base 5 of 8 equals x, and you type in log 8 divided by log 5. All right, now let's do one backwards. Log base x of, no, base 2, sorry, of, no, just did that 1 second ago. Log base x of 3 equals 18. I don't expect you to know this one in your head. I'd expect you to be able to solve it, though, by using a calculator. You should be able to get this. It's a decimal. Hint, rewrite it. It's already a log, so that means you want to rewrite it to get rid of the log. No. Logs are tools. It's just you sometimes want to use logs to solve the question. Sometimes you want to get rid of the log to solve the question. All right, so you should have figured out by now that x to the 18th is 3. Raise your hand if you got that far. Awesome. Is it solved? No, because x isn't alone yet. So how do you get that 18 off of there? Put it to the, and some of you are looking for the to the power of 1/18th button on your calculator. There is no such thing, but you could go like this. Put it to the 1/18th, and it's just a fraction. 3 power of parentheses 1 divided by 18. Why do I need the parentheses? Because otherwise, here's what your calculator will see. 3 to the power of 1 divided by 18, and it's going to go do the power first because it knows you're supposed to. You know what I mean? You don't want it to get 3 to the power of 1 is 3. 3 divided by 18 is not the same as 3 to the 1/18th. That'd be totally different. That's why you got to be careful when you put stuff in the calc. All right, so there we go. 3 power of parentheses that. And did you get a nice little decimal? All right. PM, what did you get for this spot? 1.06. Raise your hand if you had 1.06. Awesome. Okay. Now let's get a little bit more advanced logs. So if you have logs on both sides, then you can cancel them. And if so, what does that tell you that x is equal to? X must equal y. Very good. Okay. So if you have logs on both sides, you can cancel them. But be careful. If you have logs that are added to each other, like this, you can't just say, oh, Mr. Server said you could just cancel all the logs. Nope. Only if you get it down to 1 log on each side. So do you remember how to condense these two into just 1 log? All right. So log base 3 of that times that is equal to log base 3 of y. And now I got logs on both sides. Cancel, cancel, 5x equals y. That's great if they want y solved. If they wanted x solved, you just divide by 5 and you'd have x alone. Yes?
Do that number have like log base 5 times log base 2x?
Nope. These are always going to be adds or subtracts. How about subtract, though? You remember what to do on that? All right, try this one. Staring at it won't help. Rewrite the left side into 1 log. They have the same base, yes. Log, same base cancel. 5 over x equals 15. Ooh, it's a little bit icky to solve. You could always make this 15 over 1. And do you remember the old cross multiply thing? That could be done here. Or you could just multiply both sides by x and then divide by 15. Final answer, x equals 1/3 is right. Raise your hand if you had that one right. Awesome. Okay. I'm going to do one more like that, but it's got a twist. The bases aren't going to be the same. Let's see if you can you deal with it? Hint, that could be changed so that it was a 9. Then at least, even though these bases aren't all the same, at least you could kind of like fix that part and make it into a number. I know this is going to stretch some of you. Some of you, you're going to be like a rubber band that's old and dry. It'll stretch you so far, it'll break you. Some of you will be able to figure this out. I'm going to give you a little bit of time. Work on it. You can always ask kid next to you for ideas. I'll pause for a second. Okay. Did you figure out that this part was log base 3 of 10 over y? That should have been pretty easy. Okay, and then this other part, which you should have said is, okay, I should write that 3 as a 9. But how do you do that? 9 to the 1/2. Okay, anyway. Did you replace the right side with a 1/2? That was extra smart. How many of you actually got that far? Sweet, nice job. Okay, then you finish it by doing this. Anytime you get stuck in the log section of the test, I would think, can I rewrite it? Because usually that'll be the secret. I'm going to go from this form to that exponent form. 3 to the 1/2 equals 10 over y. And look, I'm almost solved. Y's almost alone. Okay? So now I'm going to multiply both sides by y. Cancels. And now I'm going to divide both sides by, what's that really? That's really the square root of 3. So y is equal to, and I'm dividing by that on both sides, 10 divided by the square root of 3. Whew, that was as tough as they could possibly be. And I know some of you left that as 3 to the 1/2. It's okay, as long as you know that 3 to the 1/2 means square root of 3. Yes? Yes, there are multiple choice parts, but there are also free response parts. So I don't know if this kind would have been multiple choice or free response, but that was about as tough as it gets in logs. Now let's talk about matrices. I was going through old ACT tests, retired ones, and I saw a question like this. And if we call this matrix A, this matrix B, and this matrix C, which ones can be multiplied? Because some of them can't.
Okay. I got it. B and C, but not A.
Okay, so you're saying B can be multiplied by C. I'm going to check you. Okay, you check yourself before you wreck yourself. I'm not actually saying you're wrong. I'm just saying check yourself, because that's the whole point of the question is, will it work or not? Okay, hint.
Yeah.
It does.
All right. So which one won't work? My question was, well, I guess I could have asked it either way. You could either say which ones would work, but which ones wouldn't work was actually the way the ACT question was worded. Which one of these would have no solution? And A times what? A can't be multiplied by either one. All right, you are correct. And it was one of those like A and B but not C, A, B, and not C, A and C but not B. Anyway, so, all right. So, moral of the story, you're supposed to know this. 2 by 2. And this is the key one, because anybody can do a 2 by 2. Is this a 1 by 3 or a 3 by 1? 1 by 3, because it's got one what? Row. Does it really only have one row? Yes, it does. 3 what's? Columns. Very good. Columns hold up buildings. This has 3 of those. And I know there's only one number in them, so it's kind of hard to see them as a column, but columns go up and down. All right. So then this one must be a 3 by 1. All right. And those two can be multiplied because look, when I set them up next to each other, the inside ones match. That's what has to happen for them to be able to be multiplied. All right. And you're right that A couldn't multiply by either one. 2 by 2 next to a 1 by 3. Why doesn't it work? Those don't match. All right. Stay focused. Stay focused. I know it's been a long time, but all right. We're almost done here. Now I'm going to give you a plain old fashioned. These two for sure will multiply. And I'm just trying to make a point here by having you multiply them this way once, and the same exact ones except backwards. Because do you remember that when you multiply them in the other order, you will get a different answer? We established that these can be multiplied, but you will get different answers if you do it one way than the other way. Go ahead, give it a try. Get the 2 answers. One's got one answer, one's got a completely different looking answer. Pause for a second while you give that a try. All right, so here's what you should have said. On this one, it was a, how many rows? 1 by 3. And how many rows? 3 by 1. And so this matches, so it's a 1 by 1 answer. That means it's a single number. What was that single number? Because you multiply 1 times 1, 4 times 0, and negative 1 times 7 is negative 6. Raise your hand if you had negative 6. Awesome. In case you forgot how that worked, I'll show you. It was 1 times 1 plus 4 times 0 plus negative, or no, 7 times negative 1. And that equaled negative 6. Okay, down here, this is a 3 by 1 and a 1 by 3. Much more of a pain because your answer is a 3 by 3 matrix. All right. There should be 9 numbers. This is row 6, person 2. That's you. Hit me. Top row.
1, 4, 7.
Awesome. Next row.
0, 0, 0.
Nice. Last row.
Negative 1, negative 4, negative 7.
You are right, sir. Nice job. Okay. So there's how you multiply matrices. Here's a twist. What if they threw a 3 right here? Then you would just simply multiply this 3 by everything in here, and then you would do the same multiplication you just did a second ago. It's called a scalar multiplication. It just scaled it up. Everything got 3 times bigger. It's really not that tough. All right, now, what else was there on this unit? There was this kind. I did this in a different hour, so I'm going to find it, pausing for a second. See the red equations? Do you get how you could write those with these matrices down here? Do you remember doing that? It's not that hard, actually. You're just plucking the numbers off, and if they don't have a number, you put 0. What if they don't have a number in front of a letter like this? What do you put then?
0.
A 1. If they don't have the letter at all, then you put a 0. Okay. All right. So how do you solve it when it's like this? Just a reminder, this is one that would go in the calculator. All right, I'm not going to make you put it in right now. You decide whether or not you need the practice. This will be matrix A, this would be matrix B, and this is a 3 by 3, and the first thing it asks you is, in your editing thing, there's a matrix button. If you edit your matrix to a 3 by 3 matrix, then you type in your numbers. How do you finish? You take the inverse, that's the power of negative 1, inverse A, and you times by what? B. You finish these with inverse A times B. That was just saying, look, there's nothing here, so what do I put? I put 0. Okay? Just calling out that there's some equations that don't have a variable, and then if it doesn't, that means there's 0 of that variable. Okay, so that was a few things to remember. Now, what do I want you to do for this weekend? I told you to do the first 5 questions of your homework, which was this big review packet thing. We have to step it up to be able to have any chance of you getting done in time. You need to get at least 15 more of them done. Somebody's going to ask me, are you going to assign all of them by the end? No. I'm not going to require you to do like 67 questions for review. But I'm going to require you to do some subset of that. I haven't decided how many, and I'm going to let you decide which ones you skip. Honestly, you shouldn't skip ones that are super hard, because if you don't know how to do it, that's the kind you should practice. But you'll be able to choose. Maybe maybe the best scenario is one you kind of think you remember how to do, but you're not positive. Do those. If they are incredibly hard for you, maybe it isn't worth spending a half an hour trying to learn something you never really understood. But don't just go do all the easy ones. If you already know how to do it, there's not much point. So do 15 more questions this weekend that are ones you know you should probably practice. Yes? There will be an answer key posted. I know there isn't yet, but it will be very soon. And worst case scenario, if you have noticed that I have forgotten to post it even on Saturday morning, you can email me, and I promise to stop what I'm doing and go find the key and post it. I'm going to post it as soon as I get it. I just haven't gotten it yet. All right. That's all I have for you for the video for today. Like it.